Well, hey guys, and good morning to you. Well, I know it's not morning for you, but trust me, it is morning for me. Right now, it is Monday morning at 2:17 a.m. Yeah, it's an early one. But in my position here, I've often find myself in this situation because in my position, other people's jobs rely on me getting mine done at a certain time. Like today, we have an integral piece of the plant, our water chiller, that needs to be worked on and repaired before first shift starts. So I'm going to try my best to get this thing up and running and functional before first shift starts at 6, 7 a.m., somewhere around there. So if you guys are familiar, I have posted a video something similar to this in the past. Our chiller has many pumps on it. Some circulate, some pump chilled water out into the plant for processing. And it's a super important part of plastic injection because we need to monitor and maintain a certain temperature of water for processes and cooling machines and hydraulic units and stuff. And it's a big deal. In order to have a plastic plant, you need to have chilled water. So without any further ado, I guess let's throw some 90s Metallica on the radio, maybe a little Go Juice in a can, and try to get this thing underway, shall we? Well guys, this is her, our AEC 80-ton water chilling unit, or at least most of what you can see here anyway. The control unit's up there. We have two back-to-back scroll compressors, and then here is the pump station that I need to be working on. So you can tell here there's two smaller pump motor assemblies and then two larger ones next to it. Well, like Sesame Street here, which one does not belong? Can you tell just by the color here that I've replaced 3 out of the 4? And if you had to put any money on it, which one of these things failed? You got it. That bluish gray one. Clean there in the back, underneath all these pipes, up close to the wall, and the most miserable freaking one to get to. Yeah, she made the old exit interview, but luckily, we're prepared. I've gotten ready for this. We have new ones. This is actually a circulation pump because I like to have stuff. But the new process pump that's going into place is in a skid right behind you guys. But I need to disconnect this thing, both electrical and mechanical, undo the flange valves, undo the foot mounting and everything, shut off some valves so this thing doesn't fly apart, yank that thing out of there, and try not to give myself a hernia in the process, and put a new one in its place. I know this sounds menial, like it shouldn't take hours to do, but trust me, I've done this plenty of times before, and sometimes you run into things. Flanges are galled, pipes break, things are rusted. It's just, it never fails that something happens that makes this take 3 times longer than it should. And if you guys have ever touched a wrench, you know exactly what I'm talking about. So I guess there's nothing left to do it but to do it. So let's get into this thing. Well, first things first, let's go ahead and not die during this process. So what we have here is the control cabinet that runs everything. The PLC, the hardware, the relays, yada, yada, yada. This giant bank of fuses here is what runs everything. These two big ones are for the big compressors. They pull the most current. These two are for the process pumps. This particular one is the one that we're working on. And these are the circulation pumps. So I'm simply just going to yank the fuses out of here so this contact is dead. So I know whenever I'm yanking this thing apart, I'm not going to get unalive by doing it. So obviously this pump isn't on because the PLC isn't telling the contactor to pull it in. But regardless, there's no such thing as being too safe whenever you're dealing with 480. So I'm simply going to yank these fuses, get everything out of the road, and make sure it's safe to work on. Take our trusty fluke. I know it's dead, but I want something smarter than me and more reliable than me to tell me that it's dead. Check between phase 1 and 3, 1 and 2, 2 and 3. Yep, everything is dead on both sides of the contactor. Everything is good and safe to work on. Now, I know this is going to be difficult for you guys to see, but it's difficult for me to get in here, period. So, yeah, you're going to have to excuse the crappy angles and perhaps lack of editing on this one, but you get me here. There is a butterfly valve here and also one right above it. You may not be able to see, but I have an intake and an output. It's a pump, right? But the pump is connected to this giant volume tank right behind me. So there's, oh heck, I don't know, 500 gallons worth of water right behind me wanting to get out as soon as I remove that pump. So step one, we got to shut off the water to this thing and minimize our risk of taking a bath at 2 a.m. And luckily, since I knew this job was coming, I have been exercising these valves throughout the last week, so I knew they would close. Because these things rarely enjoy being changed from their regular state. But now that I have those things off, now I think we're going to do the flanges next, because that's usually the next most troublesome part, is getting these things physically removed rather than electrically. Man, I just realized because of the glory of YouTube and copyright infringement and everything, I can't even enjoy my 90s Metallica because you guys won't be able to listen to it on there. So I get the awesomeness of doing this project in dead silence. Just hearing the sultry sound of my voice soothe you guys. So yeah, we're gonna be working Amish today without a radio. I don't know how them guys do it, honestly. But I guess we gonna learn today anyway. So if you guys can tell here, I've had this thing apart before because I have all of the insulation taped up. Which, I mean, I guess is nice, because it'll hopefully be a smidge easier to rip this thing down. But this old girl is really showing her age. Come on now. There we go. We're not going for pretty here, we're going for done. So yeah, I know you guys probably don't have the best view of this, and I apologize for that. But it is rough to get to this thing. So just keep on going. Rip apart this insulation here as neatly as we can. Because like I said, this thing is a chiller. And we run this at 40 degrees Fahrenheit. And this room that we're in is the mechanical room. There's air compressors in here, there's pumps in here, there's motors in here. This room gets hotter than the gates of the place you don't want to go when you die. So we need to minimize the ambient differential between these pipes and the room that they're in, because they just sweat like there is no tomorrow. And that causes these things to rust prematurely. No bueno. So, I'm going to just keep on tearing this stuff apart. And I'm sure this is boring because you guys can't see most of it. But, yeah, what do they say in Hollywood? We'll just edit that out in post, right? I'll see if I can't get in here and give you a little bit better taste of my POV, what's going on here. All right, please forgive the shakiness of the video. You guys are just in my hand here, no accessories or anything. But this is the 480 pump we're needing to change. That is the output pipe, and that's the valve we shut off there. All the insulation removed. That big chunk right there in the middle with those long bolts, that is a check valve. And then that right there is the flange that needs to come apart for the output of the pump. And then right here is the intake flange. This guy right here. That's the valve that we need to shut off for the intake, and you see how it splits off because this is a shared system. Each of the two pumps are together in tandem, so in the event that one fails, we can still limp along on the other one. I just really try to avoid that situation. So we have the two circulation that take water from the bulk tank, pump it through the circulation pumps into the evaporators under here that are run by the giant compressors, and then put the water back into the bulk tank. So this thing is constantly circulating and keeping that water at 40 degrees. And then these two giant ones here, they go up through these check valves, up through this spider web of piping, and then get pumped out into the plant. And then eventually it comes back through this return pipe and dumps into the bulk tank to be reused. So yes, this is a closed loop system, but not 100% because this bulk tank is open to atmosphere. This lid here opens so I have access to add chemicals and everything. So it's closed, yes, but it's not pressurized. So it allows me to introduce air and stuff into the system to bleed water out and everything during maintenance. But since it goes back to this bulk tank, it's open to atmosphere and that air is able to come out. It's actually a pretty snazzy system and it's good to work with. But like I said earlier, guys, please excuse the lack of good shots and footage here. But this is just a real bear of a spot to get into. Ugh. So you may see more of my hind end than you would like. But unfortunately, that's just the nature of the beast. And that's how this one's gonna have to go. Because I don't even have any room for me to get in here, let alone get you guys in here so you can physically see what I'm doing. This is just kind of a crappy situation all around. So if you guys can imagine, I am simply removing the bolts from the intake flange here. Nothing crazy. There's just 4 5/8 inch hex bolts that go through the flange and bolt onto the front of the pump for the intake. And this is one of 2 that we're gonna have to fight with. Well, we got the flange apart, both flanges, so that's good. Good news. I didn't bother showing you the other one because it would have been a lot of just staring at my butt and yeah, ain't nobody got time for that.
I got bronchitis. Ain't nobody got time for that.
But now, we're moving on to the pecker head on the side of the motor. And in case you're wondering, no, I didn't just make that up. That thing's actually called a pecker head. Ask me why. I don't know. But at least I found a way to shed some light on the situation. I found one of those old halogen lights that produce more heat than light. So that's cool. We're just gonna get a little sweaty a little faster, but at least we can see what we're doing here. So remove the cover off the pecker head. Now we know that this is dead. I'll see if I can give you guys a better view here to see what's going on inside of this thing like I can. And I tell you what, I'm glad we're doing this before we had a bigger problem. I'll show you what I mean. So here we are at the pecker head junction on the side of the motor. Take a look at this. Oh my heavens. Man, this thing, I might be willing to bet that this is a factory OEM motor. No one's probably ever been in here. Look at this. How hot has this thing gotten over the years? Look, and because it's crimped, chances are that nobody's been in here. Because if this would have been fixed or anything, this would probably be wire nutted. But look at that. Oh man, it's all corroded and gnarly, and I bet you this thing has been struggling. I am absolutely amazed that this thing didn't let the magic smoke out of it. But without further ado, I'm going to write some stuff down to make sure that I have my phasing correct with the new one. And all that's left to do is take these bolts out for the mounting feet and try my best to get this giant thing out of here without killing myself. Now, the way that I like to do this, if you guys are familiar with 3-phase motors, These things are able to spin counterclockwise or clockwise, depending on the phase orientation of how you wire this thing up. And specifically with pumps, it is a big deal that this thing needs to spin the correct direction immediately on first startup. Because the impeller, the shaft seal, everything, it needs to be lubricated and it needs to push the fluid in the right direction. I mean, in this particular case, it's not absolutely detrimental, but it is super important. So I'm going to do everything that I can to make sure that this thing is spinning the right way the first time. So I take my incoming lines. Like here we have one of the 3 voltage lines here, and it's labeled 5T3, and it goes on to the white number 2 wire in the frame. So I'm just going to write that right here on the motor. 5T3 in goes to number 2 white. And I'm going to do that for all 3 phases, so I'm sure that the new one goes back together the same way. If you're wondering, all these other jumble of wires in here, that is how the field frame is wired together inside of here. This gives you the capability so you can change it between high and low voltage. So you can run it on 240, 480, whatever your scenario may call for. In this case, 480, obviously. But all these other ones should be factory crimped together in the new one. Probably not, but there will be a diagram sticker on the side of the motor where I can orient these wires in the way they need to be. So I'm just going to go ahead and keep on doing this, and we'll keep on trucking with wiring. So now that I have everything labeled, I'm just going to go ahead and cut these phase wires because they're junk anyway. Which honestly, I may have to end up replacing this because of how far back the damage goes. Hopefully not, I don't know. Well, the ground actually still has a lug on it, so that's good. That's nice. But we very may well have to pull new wire from the base of that contact that you guys saw earlier up in the cabinet. And this is just 10 gauge stranded, so it's not that big of a deal, and I'm almost positive I have some back in the shop. Which, I mean, I was going to need to go back there anyway, because we're going to need some new bolts for the flanges. Those things are pretty crusty. But, yeah, just go ahead and remove this liquid tight connector from the base of the pecker head. Oh, there you go. There's some bushings in there. Nice. Cool. All right. So I don't know how well you can see this, but this is my incoming line voltage here. And they're not great, but they're not terrible. I don't know. This is going to require some more investigation before I decide if we're keeping this or not. But at least now we are disconnected from the machine. So I can just take these feet bolts out here, get this thing out of the road, and give us some egress and some room to get in here. We clean up the flanges, put the new pump in. Well, I think it's time for a little bit of a energy break. In case you guys are wondering why I'm doing this by myself, well, my number 2, Lamar, that you may have run into on other videos, he does a little cameo appearance here and there. He's a good dude. I genuinely enjoy working with him. But he is fortunate enough that his family is getting a new blessing. He's having a baby soon. So they are heading to the doctor today, and he can't be bothered with menial crap like going to work. He's got way more important stuff to worry about right now. So good for him, but cruddy for me because I'm here on my own doing this. But hey, man, I wish him the best of luck. I'm a dad too, and I know that's amazing. So good for him. Congratulations, Lamar. Last real step here. Just take these foot bolts out. Hopefully, won't have to fight with them too much. I'm sure a lot of you guys are freaking out in the comments section right now. Why are you using crescent wrenches? You know, that's nothing but a Swedish nut lathe. How come you're using crescent wrenches? Well, hey man, I'm an industrial maintenance technician. Crescent wrenches are my best friend. And next time you tear apart a pump on a chiller, feel free to use whatever tools you'd like. But in maintenance, rarely are you ever working on the same thing, much less the same size. Crescent wrenches are amazing. And since something like this, that I'm probably going to be putting new hardware in anyway, not that big of a deal. I just need to get the stuff out. And honestly, the chances of getting this stuff out without breaking it, or probably end up cutting it off anyway, slim to none. So yeah, crescent wrenches are fine with me. I really think, oh boy, that cruddy. In case you guys are wondering, all this white crusty junk that's all around here, that is from the chemicals in the water that have been spewing out of this pump. But the stuff that we put in it is like antimicrobial and like anti-rust additives and stuff, because we're pumping this water through molds. So it's good whenever it's flowing, but whenever it sits and it's stagnant and it's exposed to atmosphere, it turns into this white crusty crap, kind of like DEF fluid. If you let it sit out, it crystallizes. And man, it is nasty stuff. It's good for what it's good for, but whenever it leaks and dries, it turns into this. So I guess it's just an unavoidable circumstance. But yeah, I figured I might as well explain that so you guys know what this junk is. But now we have the pump motor free. Let's see if we can, oh yeah. Watch, she's gonna start puking on us. Oh yeah, oh yeah. Don't worry about that. Since we have the valve shut off, that was just the stuff in between the check and the flange. But now we have this apart. Jiminy, I wish some of you guys were here to help me yank this thing out. Now, I know this thing doesn't look like much, and I don't even want to venture a guess to what the weight is. But it's enough. She definitely got some gravity. So, I'm trying to be delicate here. Go around existing wiring. Like this wire here that I'm fighting with, this is the temperature sensor on the bulk tank. Oh, there you go. Easy now. And then there's the wire for the neighboring motor. Well, I think we're getting somewhere here. Nice. Nice. Okay, so I'm going to try to squeak this out from under my feet here. Because if I go your way, I got to go under a bunch of other crap. And I don't know. We'll see what we can get here. Okay. We're like halfway there. Of course, this thing doesn't fit where I want it to. Uh-oh. Well, it appears maybe I might have to go that way, as much as I don't want to. I don't think she's going to fit without me killing myself. Well, guys, like I mentioned, please excuse the staring at my backside for most of this. But you can tell it's a tight squeeze in here. Come on. Yeah. Woo! Now you guys can get a better look at what's going on here. This is the pump in question. Oh, hold on, sorry. This is the pump in question, and you can kind of gauge the size of this thing. I honestly don't know the weight, but it's more than what I'm willing to deal with. And in here is where she lives. There's the mount. Intake, output, that's where we're going. And you guys can see the maze that I'm trying to work through here to get everything in there. So next step, let's get some parts together and get ready for an install. Well, I guess we might as well do some prep while we have as much room as we're gonna over here. You guys can see we still have the factory paper gasket on the flange here. So that just confirms my suspicions that this is the original pump. So I'll do my best to get this thing off of here. And I can only surmise that there's one under here too. Which that may have actually come off on the pump. But either way, I'm going to struggle with this for a little while. Try to get this old gasket off. Clean everything up with a flap wheel and wire wheel, all that. Get ready for the new one to go in. Cool, now I got me a flap wheel and a grinder. See what I can't do to clean up this mating surface. I tell you guys what, thank God for cordless tools, huh? I don't know how we made it this far without them. Now this one we're just gonna have to do by braille. Because I don't know about you, I ain't sticking my head under there. So I'm just gonna keep going until this feels good. I tell you what, let's use a new age mechanic hack. Got my cell phone in my pocket. Turn on the camera in selfie mode. We can take a gander at this flange here without sticking our noodle underneath. I tell you what, I don't know if I would hang that picture over the fireplace, but it's pretty darn good. Feels good, nice and smooth. No bumps, no ruckus going on. So we have decent mating surfaces for our flanges now. And I guess now we find parts and get everything together to go in. So guys, throughout the years, since I've done this particular task before, I've put myself together a little regularly used parts shelf. Like there's some dry contacts and stuff for the chiller. And I've got a whole box from the adult Christmas store, McMaster Car, of flange gaskets for this particular gig. So here we are, look. Chiller circulator pump, chiller process pump. How about that? So we'll take two of these Buna rubber flanges, already made and cut out with bolt holes for a 6-inch flange. I know they're right, but we'll match this up to the old one to make sure everything's kosher. Got our new flange gaskets here. Looky there. It fits almost as though we planned it that way. I prefer the Buna rubber ones way over the paper because you don't deal with what I just did over there. Whenever this thing comes apart next time, this just comes off. Yes, I know they disintegrate and stuff, and this isn't really good for petroleum-based stuff, but we're moving water. It doesn't really matter. Not to mention, this gives you a little more flexibility whenever it comes to mounting. Because this stuff is malleable and it has a relatively low durometer, I can squish and tighten and maneuver a little bit more than I would with a solid paper one. So this is awesome. Let's get the pump going. Here we are. Brand new chiller process pump labeled by yours truly. On top here, Fragile. Must be Italian. I don't know about you guys, but I still get excited unboxing and getting a hold of new parts. Even though it's not mine, this isn't like an intake for an S2000 or nothing. I don't have no fancy intro music or a fast car behind me. But fine. Okay, the box is stapled to the skid. Thanks. But either way, I always get excited getting new parts. It's just that giddy thing. You guys get it. Yeah, we're going to take the easy way out here. Sometimes it's okay to take shortcuts in life. More often than not, you end up shooting yourself in the foot. But, whew, man, they do not skimp on the package in here. Come on now. Ain't that a thing of beauty, huh? Brand new gold like Iron Man. So, if you guys noticed, On the old pump, there are some auxiliary pipes and gauges and stuff that stick off of it. That was, whenever this thing was originally built, that's how you monitored the pressures, intake, output, yada, yada, yada. There was an actual analog gauge on the pipes. But since then, a lot of this stuff has been retrofitted and digitalized. So I don't need to bother reinstalling that garbage on here. I just need to make sure that all these brass plugs are in the applicable location, put this thing back in, and we can go over that step. It's super nice. Here's the part where we take apart the pecker head on the new motor and check the phasing and the wiring on this one. Because, like I mentioned, this is a dual voltage motor and it can be used for multiple incoming voltages, we may have to wire the frame in the correct orientation for our 480 supply power. So rather than fight with it over there in the dungeon, might as well do it while we're out here in the open. So I can put the frame together using the diagram sticker here on the motor. Yeah, my suspicions are correct. So here are all the wires for the frame. So we need to follow the diagram on the motor, which, in case you guys didn't know, I've made a video specifically on this process about wiring a 3-phase motor. If you're interested, check it out up here. After this one, naturally, you got to see the project get done. But if you want more in depth about this, by all means, check it out. So I figured I might as well show you guys here. Here's a better shot at the inside of the pecker head. All the wiring for the frame inside of the motor, because right here, yeah, forgive me, I'm looking through the camera here. Volts, 230 or 460. So this is a dual voltage motor. And you see here, there's a wiring diagram for the frame inside of this motor. So this would be low voltage, this would be high voltage. We need to take this one and wire everything according to this diagram. So according to the high voltage wiring diagram on the sticker here, I need wires 1, 2, and 3 to be open to hook up to my incoming voltage from the supply. Wires 6 and 9, 5 and 8, 4 and 7 need to be put together and wire nutted inside of here, and then that's what creates the field frame. So I don't know, I may speed this up, I may not, I don't know. But either way, we're going to put this stuff together and make sure everything's phased correctly. All of these wires are color coded, and this is kind of a standard, but they're also numbered. They may be difficult to see, but trust me, there is like a process here. You find the two, like we have number 5 and number 8, wind them together, and then we're going to wire nut them. And then once everything is put together satisfactorily, I'm going to go back over these wire nuts with electrical tape so we can hopefully avoid the situation like you guys saw earlier, where that crimp kind of degraded and it started to short out against the case of the motor. So I'm going to do my best to mitigate that in the future and make sure that everything's happy and put together for a long time. And the last step here, take you some Super 33 and wrap these things up really well. Because the last thing you want is this thing coming undone inside of there, causing a short and possibly an electrical fire. So make sure that that's wrapped up really well, and we know we won't have a problem until we take it apart next time. Mentioned before, we're going to go over and look at the wiring that was coming through that liquid tight because it's iffy at best. Now here we are back at the incoming voltage lines. Man, I don't know. I feel like the damaged part is gone, but I don't know. I would probably feel way better about pulling some new stuff. So let me go check inventory in the shop here and see what we got. This is just regular number 10 AWG stranded. I'm pretty sure I have a spool of it. So let me go grab that and we'll start yanking some wire. So what we got here is a brand new 100-foot spool of number 10 THA10. What we're going to do here is just remove the elbow from the end of this liquid tight and make this easier to go. Since I have everything labeled up on the bottom of the contact for this thing, I'm just going to yank these wires label them individually and push them through from the other side. I think that's just probably the best way to do this. Because if you guys have ever tried to pull through liquid tight, it's difficult on a good day, let alone whenever you're by yourself. And since this stuff is smaller gauge and THHN is kind of rigid, I think we're going to be all right just to push them through from the other end, and that's how we'll go about this. So you guys can tell here we're back at the bottom of the contact. I have everything labeled. So as long as I label everything the same going back in, it shouldn't be a problem. I just need to pay mind of what's where. So from left to right here, T1, T2, T3, as easy as it can be. I'm just going to yank these things out of here. I'm going to leave the ground in the conduit because I can reuse the ground. Pull these guys out of here best I can without messing up the ground. And then we'll push some new THHN through here and label everything as we're going. In case you guys are wondering, what is this thing hanging below the contact? Good question. This is an overload. This monitors the current that goes through it that the motor is using while it's running. And it's settable. Right now it's at 20 amps. So if for whatever reason this thing goes over 20 amps whenever it's running full load, this thing will trip out and shut it off before the thing self-destructs. So in the event like we had earlier with that wire nut coming apart in the pecker head, if that were to short out, the amperage would go through the roof because of Ohm's law, and this thing would kill the circuit before this just keeps going and pumping electricity to it. So that's cool. That's how this stuff works. So we got our spool of new wire here. Make sure that the end is as straight as it can be. And we'll start pushing. Rarely ever do you enjoy working with THHN because of its rigidity. It's kind of a bear. But in a case like this, it's actually kind of nice because we can push it through liquid tight. Well, at least a run this short anyway. So I'm keeping an eye on the other end there. I want to give myself about a foot or so sticking out of the other side, just so it's nicer to work with. Then we'll cut it off and keep on doing it. Sweet, we got more than enough sticking out the other side. Cut this, give ourselves plenty of slack. Wrap this up for next time, we'll start labeling. So we'll take our trusty Brady 21 Plus here, do some wire markers. Let's see, we got 12 to 10 gauge 1-inch wire label. I need T1, print that. T2, print that. And T3. Cool. And we can repeat that same thing on the other side. Now, in case you guys are unfamiliar with tapping new wires into a source, the way I like to do this, and you can tell that I've been in here and done it before, is I like to incorporate a strain relief loop. So it's not going right out of the overload directly into the liquid tight. There's this loop here. So not only does that make this easier and give me more wire to work with up here to get it into the overload, but on the other side, that gives us a little bit of wiggle so we can pull things and maneuver on the motor side of the conduit. So this is just a good way to do it. I'm going to go ahead and start labeling these things, and then on the other side, we'll just tug and we know which one's which. Here we go. T1, T2, T3. So we might as well start with T1, work from left to right here. Give ourselves that little bit of loop. Maybe open these up just a skosh more here. Terminate our supply lines into the overload. Make sure everything is appropriately cranked down. Now you guys can see what I mean about this service loop here at the beginning. This makes this so much nicer to work with, because I actually have room to get my fingers in here. And last but not least, T3. All right. Now everything's good and secure in there. I can tidy up this loop by pulling on the other side, and by doing so, I will know which one's which, and we can label the other end. So I got me some labels for the other side here. We'll start yanking, and then I can tell which one's which. This one is T2. This one is T1, and we don't need to do the last one. Sweet. So the next thing here, I want to check the fitment of this elbow and the pecker head on the new motor. If it's cool, awesome. If not, we'll find a suitable replacement to make sure everything's good. Well, the KO hole on the new motor is bigger than the last one, but luckily we have some bushings here so we can make it work. This should fly just fine. Alrighty, campers. We're getting close to the finish line. At least I can see it from here anyway. Now we just got to do the same thing in reverse and try not to die. Oh. Yeah, she's got some gravity. There we go. Come on now. What? Up. Come on. Atta girl. All right. We're getting somewhere. One more big push. Come on. We're almost there. All right. All right. We're up on the mount. That's the majority of it done. Now, I think we're going to replace some hardware. So let's go back to the shop and look for some new bolts. Cool. So now we're back here at the infamous bolt bin. 5/8 11, just as I suspected. So we have, we got a runner. We got these 4 longer ones for the top flange on that check valve, but these were way too long. So we're going to mitigate that and go one step below what that was. That'll work there. So we got the check valve taken care of, and the pump flange. Well, that one appears to be an in-betweener. So we'll just go ahead and throw some lock washers on there and take up that 1/4 inch difference. And it's not a bad idea to use lock washers anyway, right? We got our pump pretty much in place. Whole stack of brand new hardware, some brand new flange gaskets. I guess we'll wrestle this thing up close to being into place. And then start the bolts through the flange on the pipe here, hang the gasket, and then start putting everything together systematically, if you will. I'll take our shorter bolts here with a lock. Start those in through here, make sure our gaskets are as clean as they can be. hang that flange gasket on the bolt. Prep the other gasket on top. Because of the construction of this thing, they kind of both need to go on at the same time. It's a little bit of a bear. But it's doable, trust me. It's just a pain. Boy howdy, that's close there. See if we can't start a bolt to help our situation. Well, that's kind of in there. At least we got like half a thread. There we go, that's a little bit better. Run these in just a smidge so I don't have to worry about this thing popping off and taking out a finger on me. That's super close. Now, we start the bolts through the top flange here. Wiggle everything. There goes one. I can't believe that actually went together like that. So we'll start our longer ones with a lock and a nut. Try our best to get these bottom ones in and started as well. And then before we tighten everything down, I'm going to go ahead and put some new bolts in the feet also, but I'm going to start those before we tighten down these flange bolts. Because if this thing gets kinked out of position a little bit, those feet bolts are notoriously a mother to put in. Because once everything's tight, you're not going to be able to move the motor. So I do my best to get everything in and lined up before we start tightening. Believe me, you learn that the hard way. All right, we're back at it. I got me some new fancy 3/8 grade 8 hardware here for the physical mounting of the motor to the bracket. So we're just going to do a traditional stack here. Bolt, flat, flat, lock, nut. Get everything started so I don't shoot myself in the foot whenever everything's tight and nothing wants to go back together. I am going to go ahead and tighten up the intake flange first because this is the immovable one. Once ever this one's tight, snugged up and where it needs to be, then I can tighten this one because this has a little bit of give. Man, I feel like I'm getting a suntan sitting right next to this stupid halogen light. Thank God for LEDs. We've really come a long way. Cool. So that one's in and tight. We'll go around and do the same thing here on this top flange. Get everything snugged up, do it in a star pattern just like you would with a tire. Cool. So we got both flanges tightened adequately. Last step for hardware is to tighten down the bolts for the mounting on the feet, and then we can start electric. Oh, cool. All right. All the nutting and bolting is done. Let's get on to wiring. Well, guys, again, I apologize for the lack of angle here, but unfortunately, it is what it is. So first things first here, need to install our bushing onto that 90 that will allow this thing to index properly with the knockout and the pecker head. We got everything in. We'll secure the top of that liquid tight with our second bushing. And finally, we get our nut onto the 90 and permanently secure everything where it needs to be. Now, I'm not crazy about reutilizing that plastic 90, but hey, it is what it is. I guess if that was factory, it was good enough for them at one point, so whatever. Everything's in there, it's secure, it's safe. Now, all we have left to do is terminate our supply lines and the ground. And then we'll do a smoke test, open up the valves and get this thing running. We might as well just go ahead and get our ground connected first, get that out of the way so we can tuck everything back in there nice and tidy. And luckily, our ground still has the lug on it. So that'll be nice and easy to put up in there onto the ground stud. Say hello to your new home, little buddy. Hopefully you're there for a long time. All right, the ground is secured. Our field is wired for high voltage. The only thing left to do is snip off our incoming line. Get rid of that extra. Go ahead, strip these back about 1/2 inch or 3/4 of an inch or so. Give ourselves plenty of room to get under that wire nut. And now, here's the part where I refer to the notes that I took on the old motor, so I'm sure that the phasing is correct. That way I know this thing's going to spin the right direction the first time I start it up. So, in this particular case, according to my notes, number 1 goes to number 1. How convenient is that? And input number 3 goes to motor tap number 2, the white one. Now, just like we did on all the other ones here, we are going to electrical tape the crap out of these wire nuts. Because the last thing we want is a short, either phase to phase or phase to ground. Either one is not good. So we're just going to tape the dog snot out of these things. Uh-oh. If I can make my fingers work. Sweet. Okay. Now comes the fun part. I'm going to open up the water valves and number 1, check for leaks at the mechanical connections of the pump. Then number 2, I'm going to leave the pecker head open just like it is right there with all the wires sticking out of it. And I'm going to bump the motor over now just to check the rotation of this pump. In case I need to switch it, I mean I shouldn't since we did our due diligence, but if I need to switch it, everything is out right there ready to go. So we're going to open up the valves and give her a good old test. Cross your fingers, fellas. Here comes the water. There's the out. And then this is the big one here. If she's going to leak, we're going to know right now. I think we're good. I don't know if you guys heard that, but the water from the tank rushed in and submerged the impeller. So I think we are good. Good enough to try and bump this thing over. Let's see what you got. We're going to go ahead, reinstall our fuses for all those wires that we just replaced. We know everything is installed on the other end. It's wire nutted up, it's taped up, everything is safe, it's good to go. So the only thing that's left is to power this thing back up, hit the start button. I can run over there real quick, check rotation. If it's good, awesome, we'll shut it down and finish up. But if it's not, slam the e-stop real quick, shut it off, then I can change the phasing on that wiring and get it spinning the right way. So we'll close this guy up. The PLC is up and running. The only thing left, hit the go button. It's almost like I did it on purpose. She's spinning the right way. So doing that and taking the time to make sure everything was right was worth it. Now that everything's spinning the right way, it's doing what it's supposed to do, we can shut this down and finish wrapping up the wiring on that motor. Sweet. Now we know for sure everything is good. Everything's spinning the right way. Our wiring is secured. It's done properly. Everything's in the right location. The only thing left to do is a little bit of wire management. Try to shove everything in here so it's neat, but not too packed, I guess. And plop back on the cover. And the last thing that I like to do whenever I install a new motor or a component in a machine is I label when I put it in. So this guy was installed 9/11/23. Well guys, I don't know about you, but I think that is a job well done. We're pretty much wrapped up here. The only thing I have left to do is reinstall that insulation around the piping so it doesn't sweat real bad. But that's not that big of a deal. I can do that once everything is running. We're getting close on the hour here that I need to actually get out there and fire up the plant in anticipation for first shift to start. So thank you guys for hanging out and tagging along, doing this job with me. Hopefully you enjoyed it, and we'll see you next time.